Hello class 10. Today in this video we will see the relationship between the areas of similar triangle and the corresponding sides. Now we have a theorem 6.6 NCERT textbook. This theorem says the ratios of the areas of two similar triangles is equal to the square of the ratios of the corresponding sides. So let's see what that means. Now if these two triangles are similar, here triangle ABC is similar to triangle DEF. Here if triangle ABC is similar to triangle DEF, then what the theorem says is then the ratio of the areas of these two triangles, that is area of triangle ABC and area of triangle, the ratio here, this is equal to the squares of the ratio of the corresponding sides. So we're going to take the squares of the corresponding sides, AB square and DE square, their ratio, and this is equal to BC square by EF square, and this is equal to AC square by DF square, AC square by DF square. Now this is what the theorem says. Now we will try to prove this. The ratio of the areas of two similar triangles is equal to the squares of the ratio of the corresponding sides. Now to prove this, we need to draw two similar triangles here. So let's draw two similar triangles. A triangle, let's call it ABC, and then another triangle here. Let's call it DEF. Now let's write given here. Now we have two similar triangles here. That these two triangles are similar triangle. We don't need to prove that these two triangles are similar. These two triangles are already similar. So here we will say triangle ABC is similar to triangle DEF. This is what is given in the statement. And now what we have to prove is we're going to prove that the ratio of the areas of these two triangles, that is area of triangle ABC by area of triangle DEF square, AC square by DF square. Now to prove this we need construction here, so we'll write here construction is, let's draw a perpendicular from A on BC here like this, 90 degree, let's call it D, and a perpendicular from D on EF, let's call this M, and let's call this N. So we have two perpendiculars drawn from A on BC and D on EF. So here AM perpendicular to BC and DN perpendicular to EF are drawn from A on BC and D on EF respectively, and these two perpendiculars, this perpendicular AM is intersecting BC at M, intersecting BC at M, and this DN is intersecting EF at N, intersecting EF at N. Now let's prove this. The first step, what we're going to do is we will use this. We will take this one. Now we have triangle ABC similar to triangle DEF. Now we're going to recall what happened when two triangles are similar. Now there are two important points that we have when two triangles are similar. The first one is the corresponding angles are equal. So angle A and angle D are equal, angle B and angle E are equal, and angle C and angle F are equal. So that is the first point. So here angle A is equal to angle D, and angle B is equal to angle E, and angle C is equal to angle F. And also, when two triangles are similar, the corresponding sides are proportional. That is, AB by DE is equal to AB by DE is equal to BC by EF, BC by EF is equal to AC by DF, AC by DF. So this is what we got when two triangles are similar. So here, since the two triangles are similar, we have here AB by DE is equal to BC by EF is equal to AC by DF. Okay, let's call this 1. Now second step is we will try to prove that these two triangles are similar. These two triangles are similar here. Now we will try to prove that these two triangles are similar. So now here, just now we have shown up here angle B is equal to angle E. Here in these two triangles, this angle B and angle E are equal, and by construction we have this is 90 degree and this 90 degree. So two angles of this triangle is equal to two angles of this triangle. So which gives us, by AA similarity, these two triangles are similar. So here now we will say here in triangle ABM and triangle DEN. So in this two triangle here ABM and DEN, angle B is equal to angle E, angle B is equal to angle E, shown above. Just now we have shown above. And also angle AMB is equal to DNE, angle DNE. This is since each of them are 90 degree by construction. So now here, since the two angles of one triangle is equal to two angles of another triangle, therefore by AA similarity these two triangles are similar. Triangle DEN. So this is AA similarity, by AA similarity, AA similarity. Now what happens when two triangles are similar? The corresponding sides are proportional. Therefore AB by DE is equal to BM by DN, BM by EN will be equal to AM by DN. So I'm going to take the last one, AM by DN, AM by DN. So let's call this 2. Now from 1 and 2, what we got is this is equal to this, and again this is equal to this. So here AB by D is this one, is equal to AM by DN. So all these are equal. So from 1 and 2 we get, from 1 from 1 and 2 we get, let's say A is equal to B is equal to C, and again A is equal to D. Then from this two we can say that A is equal to B is equal to C is equal to D. So everything, all these are equal. So that is what we're going to write here. So AB by DE is equal to BC by EF is equal to AC by DF. This is equal to AM by DN. This is equation 3. Now third step, the third step that we're going to do is we will divide the areas of this triangle by this one, by the second triangle. So third step is area of triangle ABC divided by area of triangle DEF. This is equal to, we're taking the ratio now. We all know that areas of a triangle is half into base into height. So area of a triangle is half into base into height, perpendicular here. So area of triangle ABC, area of triangle is ABC is half into base here. Base, we're going to take BC. So if base is BC, then height is perpendicular is this AM. So it's going to be half into BC into AM. Half into BC into AM. Again, similarly, area of triangle DEF is half into base EF into height DN, perpendicular here. Half into EF into DN. So half into EF into DN. Now this half and half we can cancel, and this is equal to BC by EF. You can write BC by EF together like this here, this two and this two. Now you can write here AM by DN. So we're going to use 3 here. BC by EF into AM by DN. So in place of this AM by DN, we can write any of this because all these are equal. So we're going to write here BC by EF. So BC by EF. Now this is equal to, now BC into BC is BC square by EF square. Now what we got here is this area of triangle ABC by area of triangle DF is BC square by EF square. So you can just write here, therefore area of triangle ABC by area of triangle DEF is equal to BC square by EF square. Now let's call this 4. Now we are going back to 1 now. This is 1 here. Now AB square by DE square is equal to BC by AB. Now AB by DE is equal to BC by EF is equal to AC by DF. What I'm going to show is, now let's say X is equal to Y is equal to Z. Now if these three quantities are equal, then their square will be also equal. So X square will be equal to Y square is equal to Z square. So here, since these three quantity are equal, their square will be also equal. So which means here area of triangle ABC by area of triangle DF will be equal to the square of all this, because this is equal to the square of one of them, that is BC square by EF square. So finally we can write here from 1 and 4. Finally you can write here from 1 and 4, from 1 and 4 we get area of triangle ABC by area of triangle DEF. This is equal to AB square by DE square is equal to BC square by EF square is equal to AC square by DF square. Hence proof. This is what the theorem says, and we have proved the theorem.